Welcome everyone to this week's SIG Node meeting. It is March 11th in 2025. First up, we have Satiris and Franchia. I'm not hearing anything if someone's talking.
Hello, can you hear me?
I can hear you now, yes.
But I cannot hear you.
Well, I can hear you. Maybe we pop ahead a little bit and then circle back while audio issues are debugged.
Can you hear me now? Or
I can, yes.
okay, now I can hear as well. Okay, sorry for that.
Great. Fine, you have the floor. Do you need to present or anything?
Yes, can I please share be able to share?
You got it.
Okay, can you see my screen? Okay, so hi, I've put in the agenda a small update and a requirement and an open question to the community about the static CPU management policy alongside in-place port vertical scaling. So we have an open item for discussion and we need your feedback. So what is the problem that now we are facing? We want to retain the application performance CPUs during scale down and scale up when we have the static policy alongside in-place port vertical scaling. So I think now it's a good time to open this requirement in the community because we are close to go to beta, and now we are planning to do the refactoring and update this PR with the new beta that is going in soon, and this question will arise. So why? What's the motivation behind it? I think it has been also commented a long time ago here in this in the core binding by Alexander, so it's not something new here. The problem, it's very simple. It is that, I'll go back. So let's assume that we have the in-place port vertical scaling, and we have a typical application which is a DBDK or a like application, which runs in a container. So typically we have, if this is the container, we have worker threads, which I can assume, for example, this DBDK worker threads, which usually they are pinned, and we want those to be retained, those CPU, that they are pinned for the performance aspects. And then you have internal application threads, which might have the business logic or the algorithms that process the packets. So in this example, within place port vertical scaling with policy static, when we will scale up, we want to be able to to keep those two CPUs, which are the worker threads. And then in this example, let's assume we have a PC with 8 CPUs. When we start, we have 0, 1, which are the DBTK or the worker threads, 2 to 3, which are application, and then we want to scale up with 2 CPUs. In this case, we assume 5 and 4 are being used by another container, and then the available ones are the 7 and 6. So you see in this case, when the in-place port vertical scaling up has been done, the container is pinned with the four CPUs that it had plus the two new ones. Now, when we scale down, we want to be able to specify in the patch command which CPUs to maintain. And then when it will scale down, we'll keep those for existing CPUs. So this is very important in applications where usually when we have CPU pinning, we want to maintain those because otherwise we're going to have an impact in the performance application if they are not retained. So this is the motivation of this extra requirement. And now checking a little bit the code during the last months, I have found out that actually, as it is now, in the end, it will call the CPU set, which currently it's an ordered set. So it doesn't have a last in, first out logic, the CPU set as it is today. So in this case, I have thought like some solutions. I mean, one is perhaps implement a last in, first out CPU set and use it. In this case, the application will utilize the LIFO in the CPU set, and then internally it should have the logic to utilize this. I mean, the cons in this approach is that it will not be possible to specify explicitly the CPUs from an outside the application. Another approach, without modifying the CPU set, so keeping it as it is what we have today in the commit, where we have improved the CPU mapping algorithm, where it's very simple what we have added. We have modified the CPU assignment and the CPU accumulator to take two additional parameters where we specify the reusable CPUs for resize and the ones that we must keep for scale down and some logic. I will not go with the details. So this solves one approach, and this alone solves the scale up because we have the maintaining. But in order to solve the scale down, we need to specify the CPUs to maintain. So here in the discussion in the PR, there were several, two options I have thought about. It's either we introduce in the Kubernetes API one mutable container in resize policy, which or to solve this through an environment variable, which I was fortunate and a contributor from the community, Kunchia, I don't know if I pronounce correct the name, she has made a proposal which currently in the PR exists today, which actually implements this thing, the must keep CPUs, with an environment. And the process that you can specify. And with this opportunity, I would like to, if Chungchia, you are in the meeting, if you can share your screen and go present a little bit of your proposal. So I will stop sharing, I think.
Hello. Yes, can I share my screen?
Yeah, I think so. I don't know if
Yes, you can now.
Okay. Can you see my screen?
Yes, we can.
Okay. It's the first time my attending this meeting, and hello everyone. My name is Chunxia, and I'm from China, and I'm working for Samsung, and I'm glad to be able to attend this meeting. Maybe my English is not very good. If there's anything unclear during the explanation, feel free to ask me anytime. Now let's start. For the option 2 that Mr. Steers said, and for our option 2, we try to add the master keep CPU's interface in the environment like this. The environment is a parameters for the in the containers, and we can add, delete, and change the value of the must keep CPUs. And if we add the must keep in the environment, and we do not need to add new field in the container structure. And this is the first method to add the must keep interface. And we have another method, but it is same as Mr. Steer's option 1. It is to add a new field must keep in the container structure like this. And maybe this is more clearly, and but it should add a new field in the container structure. And in this PR, our PR implement is our PR implement the method 1. And in this PR, we have another part of this PR. It is for the another part is for a proposal for CPU allocation strategy when pod scaled. And in this proposal, we have considered 2 functions. The first is for the tick by topology NUMA pact, and another is the tick by topology NUMA distribute. And for the first functions, our proposal consider the combination of the exist CPUs and the newly additional CPUs are in same socket on NUMA nodes or cores as possible. Yeah. Do you have any question?
Well, there are questions and comments, but please finish until the logical point, and then we can do the comments.
Fully agree.
Me and
Exactly.
Francesca, I think we have to.
Exactly. Fully agree. Please go on.
Okay. Okay, for the in the steps in the scheme 1, the steps in the scheme 1, it is the steps for the pod create. And firstly, it will take the full first level. If we assume the sockets are higher than the NUMA nodes, and it will allocate the new CPUs in one socket. And next will take the second level, it is a NUMA node, and then take full cores, and the last is to take the remaining CPUs. But we considered a scheme is that if we not consider the exist CPU for the pod resize, and maybe the step of allocate the newly added CPUs can as below. And the scheme 2 is for my proposal, and our proposal to consider the exist CPUs. And in this proposal, we add some steps before the step of the pod create. For example, before take full first level, we should take the first level for the resize. It means allocate the container CPUs in one socket. The container CPUs means existed allocated CPUs and the new allocated CPUs. And then the second is before take full second level, we should allocate the container CPUs in one NUMA node or within the same NUMA node to allocate a NUMA node. And the 3 step is before the full cores, we should take the full cores for the resize. It is allocated the container CPUs in one core, or within the same NUMA node, or within the same socket. And the last is to allocate the remind CPUs and keep the container CPUs in one NUMA node or socket. And here I give some examples and the comparisons of the scheme 1 and scheme 2. For case 1, the pod resize CPUs from 2 to 16. And in this picture, the CPU 0 is for the reserved CPU, and the yellow CPUs is the CPUs have allocated to other pod. And the pink CPUs is exist CPUs for the resize pod. And if we not consider the exist CPUs in the scheme 1, and we will allocate the CPUs by the take full second level and full cores, and allocate the green and blue cores. And this will cause CPUs of all of the CPUs of the resize pod across the sockets. And if we consider the exist CPUs, and we will use this function, take full first level for resize, to allocate the CPUs, allocate the remind of the CPUs for the socket 2 to this pod, and all of the CPUs of the resize pod are in one socket. And for case 1, for case 2, the pod resize CPUs from 2 to 8. And if we not consider the exist CPU, and we will allocate them, allocate another CPUs across the sockets. But if we consider that, and we allocate them with take full second level for resize, and allocate another CPUs within the same socket. And the case 3 is for the remind CPU, is an example for the remind CPUs for full cores. And the case 4 is remind CPUs for resize. And both of the case 3 and case 4, for when we consider the exist CPUs, and all of the CPUs for the resize pod will be in one socket. And if we not consider that, maybe all of the CPUs of the resize pod will across the socket. So if we considered it in the scheme 2, it is a better choice to allocate the newly added CPUs. And this is for the first functions. Do you have any questions?
Not a question, but a general comment. So we don't need to create additional policies on resize. So that will create problems in debugging and understanding how it actually works. So we have a static policy. We have code which implements the options. We have a code which does the allocations based on those options. And well, there are also like cache criteria and so on. So we don't need to create another set of logic about the sockets and so on. So what needs to happen on the resize of a pod? We need to try another allocation in an existing policy and using already allocated core as a hint. So practically, if we cannot fulfill the same criteria as the initial allocation in the policy, then the update operation should fail. So we cannot resize, we cannot break the initial policy constraints.
Yeah, but I think, but what is your opinion about the environment to specify the CPUs?
Regarding specify the CPUs, so you outlined 3 options, but actually you haven't looked at the most obvious option. So we have internal state of CPU manager, and we have the allocation which was done when the pod was admitted and container started. So those on the container start CPU cores, it's the ones which we promised for DPDK and the like applications. Those we cannot change. So anything else what is added or removed later, it's non-guaranteed in a sense, CPU core. So like application should not rely what those will be present. In your scenario, so like if we are scaling down, you just need to make sure what we are not scaling down below that initial container creation CPU set.
Yeah, but with this one, the word that I found is that the CPU set as it is now, it always returns unordered.
You don't need to the same. Okay, let me say it differently. You don't need ordered CPU set. You need to store additional field in the CPU manager state what was allocated in the beginning when the container started.
Yeah, this I have it, but the problem is that in some container, I mean, the design pattern to have it separate, one container specifically for DBTK, let's say, and then a separate one for the application logic. Sometimes this design pattern is not the best one from performance point of view. So sometimes they need to be in the same container. So somehow we need.
CPU set is per container, and allocation is also per container.
That's correct, but the problem is.
Let me try to explain. So container has the life cycle. When container is created, you have initial CPU set. Save it in CPU manager state and don't touch it anymore. Any kind of updates, it will modify another variable, like the the current CPU state. And when you are scaling down, you just need to make sure like you are removing the CPU cores, which is not part of the initial state. And that's it.
Correct. But in order to do this, so look, when I will scale up, then I have an extra 2 cores, which I need then to scale down. So what I notice is, as it is today, when I was doing the scale up, it was remaining it. So I have already in the PR this logic. But after the scale up, when I was doing a scale down, it was interesting because it was returning an order set from the CPU set. I didn't have a control to specify the 2 first. And for this reason, I had to create this extra with environment. So, I mean, now we have, I mean, I'm specifically for the interface, to say somehow they must keep CPUs. I mean, if I can, sir, I can show you this explicitly. I mean,
you are trying to fit the 2 states into one variable. I'm talking about the 2 independent variables.
But Sasha, your approach is very interesting. But this also would mean that a pod which is resized, I mean, is kind of different because it's basically the initial set plus a patch. I'm oversimplifying, but that should be a reasonably decent initial set.
Initial set and actuals and current state.
Yeah. And current set, which is, if I understand your proposal correctly, is going to be a superset, some extra CPUs, which those are the one which we remove, right? Is this correct? What you're suggesting?
Yes. So the current state would be sum of initial plus what we added.
Perfect. But
when we are removing, we are just removing from this superset, but don't touch the ones which was initial.
Awesome. This means we cannot ever scale down below the initial set. I mean, I can
and that's exactly what we shouldn't be doing right now. Okay. So for guaranteed pod, for guaranteed QoS, if we start a DPDK application, we shouldn't be able to scale it below the initial request.
Yes, totally see the case in DPDK, but in general, I mean, is the DPDK use case posing, I'm just really asking, is this DPDK application posing an extra constraint over the general feature? Are we happy with that?
Well, let me say yes, because the whole CPU manager policy, what we have in current state, we have DPDK as a like primary customer.
Okay.
That's one thing. Second thing, even if we forget about the DPDK, we just breaking the promise what was done in the past. Like it's unwritten promise what if you got the exclusive resources allocated, we are not change it during the lifetime of a container.
My only comment, and then I'm gonna shut up for a few minutes, is that we should make that promise explicit.
We probably should, but with implicit promise.
No.
I know like a lot of applications which depends on it.
Absolutely, this is why I'm saying we should make it that explicit, because it's kind of explicit, so we are all happier. Yeah, don't want to monopolize the conversation.
Yeah, but it's great. Thanks for the comments. I mean, we wanted to show you this PR, the lesson that we have, and would like to feel free to a little bit to comment in the PR to find a solution together. Dawn, I see you have your hand raised.
Maybe Alexander, can you hear me? And maybe Alexander already covered what I in my mind. I do think about I like all the things. Thanks for the presentation and all the Chunxia's presentation cover all those kind of the rules, schema, expectation. Actually, I do agree. Everything's agree. But I do think about that's supposed should be of the implementation detail. We try our best to follow the rules. That's our core allocation or CPU management, or it is the CPU pinning policy based on that one. Because the application ask for CPU pinning, they all have the performance requirement. So naturally, you want us when you expand it or shrink, you want to still those CPUs stay with the same Newman node for the faster access of the memory. And also within of the same circuit. This is just like for sure. This is absolutely we need to follow. So that's why more it is implement detail for we need to revamp of the CPU management. I think everyone agree on this one. So then a second one is I personally don't like the proposed API, and because I think luckily for the pod, the in-place pod resizing, luckily we agree we need a checkpoint. We do agree a checkpoint, right? So we do know for this. We also know no matter it's the API server. I'm not sure. Team, correct me. Do we still have the initial side? This is maybe Alexandra tried to suggest we already have the initial set of the CPU alignment, even like the using those kind of things. I like what Alexandra said, like the no more down to less than or smaller set than the initial set. Because you have the performance requirement and then you down to that one, then you definitely have the have some problem. You even more facing about the potential facing of the lossy neighborhood problem even. So that's why at least we can shrink of the CPU pinning, but no the minimum. We could have the policies, the minimum it is the initial set. So that's at least that's kind of the.
So your proposal down is to checkpoint this info, correct?
We already checkpoint. We can checkpoint.
But we are checkpointing now.
Yes.
Sorry, but we are checkpointing the total, correct? But we are not checkpointing the initial CPUs. We need somehow to add a new variable to checkpoint this additionally.
But for me, the auto is implemented in detail without.
Okay. Now I got you.
We could emphasize follow all those rules, right? So those rules for the CPU, and also one rules which you just start from beginning, last in, first out. So add that rule and also all those presentation rules as the basic rules for the performance.
For this LIFO, it would be easy, I mean, with the CPU set, but I understand this. I would like also your feedback because, I mean, as you see now, the implementation of the PR, I mean, the only solution I found it was to modify the new CPU accumulator, adding those two variables. And I guess if we checkpoint it, then but we clearly need your help to improve it. And I mean, it's so it's much appreciated. And yeah, I don't have any more. I mean, I had more questions in this meeting, no answers. But thanks for your input. And yeah, I don't know if someone else want to ask or.
Few more comments from my side. So one comment, if you really want to have a generic case and you want to scale down like below the initial container creation resources, when it means what we cannot, how to say, we cannot do resize without restarting of a container. So if you want to go lower, when you need to restart and when all the assumptions of which initial CPU set were allocated are broken, so then you can reallocate whatever you want. But again, like according to the existing CPU policy configured on the node. That's one thing. Regarding all kind of API changes and downwards APIs. So right now, there is no downward API from CPU manager to the container. And exposing it as variables is not good because we cannot change that dynamically, like when the containers are resized or, well, for containers which are using the shared pools, it's also not viable solution. We can try to introduce it in normal downwards API, what Kubernetes is providing other files. In that sense, when application can subscribe to iNotify for those files and see if something is changed. But again, like for DPDK applications, it still will be problematic. Regarding the pod spec, which says maintain or retain CPU number something, that's fine for single pod, but that's not fine for like if you have cluster with dozens or hundreds of thousands of pods. So on each node, the CPU numbers will be different. So you shouldn't be having in the spec in any of the fields hard-coded values of a particular node, particular CPU core, or particular memory zone, or whatever. So you just like with design principle, you describe what you want, and the node or orchestration layer will provide you what you need. So this internal details, which cores to maintain, which cores needs to be staying, it's internal state of a kubelet on the node.
What's your opinion about the LIFO approach?
As I said, I don't like it. One of the reasons is what this API CPU set is exposed not only inside kubelet, but it's publicly API to something else. We don't know what kind of projects are using what library.
No, I was thinking to create a new CPU set with ordered. That's
yeah, but still, I'm a bit conscious about touching this part of the code. Anyway, as I said, like what I see what it can be solved a lot simpler with just saving the state what was the CPU state on the container creation time.
okay. Then we can continue on this subject. Yeah, I think I see Swati and Marunal. Thanks.
I had a quick comment. I think it ties into what Sasha was just saying. Exposing in the pod spec CPUs to keep or CPUs to remove kind of has the assumption that we know the CPUs that were allocated to that container, but that's not exposed, outside of the node, other than if you were to, gather the state from the node itself or determine the state within CPU manager. So this is all implementation detail, and exposing that through the API is something which I'm not sure is the right thing to do. So I just kind of want to mention that. It kind of ties into what Sasha was saying, exposing implementation detail at the pod spec level is not what we were aiming to do with CPU manager. It's a contract that we ask for, say, 2 CPUs, and that would be given to the container.
Okay. Thanks. Mrunal?
Yeah, so I think I agree with most of it. I'm just a bit concerned whether we can get by with not having anything in the API to indicate that the initial one should be retained. And can we just get by with kubelet checkpoints for ensuring that?
So Manu, you have concern about that one?
Yeah, Don, I'm like, what if the node goes away or there's a higher level controller creating these pods? So I'm thinking like, do we need a field or something that that lets us remember that this is what was initially set, so we never go below it?
So your concern it is so the pod in place update increase about the CPU and then but the node go away. So the pod is moved to another node. So then the initial state it is going to be like from the 2 to 4, the initial state before. So the minimal cannot go down is the 4.
Yeah, exactly. So if we don't remember what we started with, then if the node state may not be enough, is what I'm worried about.
Yeah. Just to make it clear, the scale up, it works as it is, even without the environment, without putting anything. The scale up sufficiently runs until you restart the kubelet, which you are correct. In this case, we need the checkpoint to do it. Yeah.
No, I think even if the node goes away, it gets rescheduled on another one, then we don't know that we're not supposed to go under a certain number of CPUs.
I don't think that's the problem we should handle, because that's the
I mean, that's okay if we don't handle it, but I think we should at least say that can happen.
I shouldn't put it this way. It's not the problem I should handle, because I always think about there's a separate problem with this resizing. I always separate off the initial request. This is my problem. Okay, sorry. So I always, at least when I talk to VPA team and also other people besides this pod in-place resizing, because pod in-place resizing is like the node feature, right? To make that useful, you need to integrate with either generic VPA Kubernetes offer, or it is I really like of the workload specific auto scaling, and which is aligned with what I proposed support the batch workload, right? So in that cases, they need to understand it. We need to separate about the initial request from this dynamic adjust of the resource request and limit. Because initial based on the historic data, all those kind of things, and start from there. And this pod resizing is a lot of the time is based on the demanding, based on some peak usage to handle about the fluctuation of the usage. So this is my problem, because I always think about this way. But the use case, the case scenario described is real. Another thing is actually I do realize I'm missing one particularly really important use cases when I say that it's not when it is use cases like if we want to dedicate some CPU. So like right now we think about the pinning, it is most of today we talk about is most for the performance boost. But there's another one, it is we want to jail somebody. We want to put someone constrained, not using other CPUs. For example, for certain cases, like the telecom use cases, they don't have much of the Kubernetes usage and the container D usage, right? So and also there is that batch workload type of the things. They want to constrain them no more than 1 core or 2 core together. How am I going to describe that one? At least in the earlier, right? So they won't be luckily, most cases, maybe they don't do the in-place pod resizing, but But we still need to consider, because that's the case is how we jail. Because besides them, there maybe have some application we want to jail the customer like best effort of the bench workload. They kind of the most they just try to using whatever available resource like CPU resource. But in the future, we worry about for certain they want to bin pack more, but at the same time they have the high performance workload. So they want those best effort to stay away from those CPU, and they want to constraint of this.
Yeah, I
What
think
we
that makes sense, and I think we had the strict CPU reservation work going on, which is doing that, right? Doing the jailing part. Yeah.
yeah.
Can you share in the chat, Mrunal, what you are referring to?
I'll get a link. I believe we have a feature in progress that can help with like strictly keeping the system daemons on specific cores. There's the strict CPU reservation. Okay, Francesco, if you remember. Yep.
Okay. Thanks
Yep.
for your input. Yes.
Just one last question I have is how would you validate that the CPUs that are provided as part of the, say, must keep and must remove is actually matching to the ones that were allocated to that container? Because you could essentially put anything and it could conflict with what is already allocated.
This we have it already in the code. I mean, if you see here in the commit, we are checking the reusable CPUs, which CPUs exist, and currently it was universal, independent of the topology. And so in the commit as it is now, we have a housekeeping, but it's not checkpoint in the file. It's internal in the code. So here is in the CPU assignment. I think it's in the code. Yeah, you can contact me offline to give you more. I mean, I don't want to take the whole
Thank you.
meeting. Yeah. Okay, thank you very much. I appreciate your input. Yep, I will stop sharing.
Okay. Yeah, thanks for that lively discussion. So we have like 11 or 12 minutes or so. We had one from Shriram. Was this just a call for review, or was this did we have things to discuss with the container stop signals?
Yeah, I'll be quick. So mostly it was to start the review early because code freeze is next Friday, I think. And I had a question about the API review. So currently I tried setting the container state, the stop signal as a enum in the CRA API, but then it falls back to the 0 value as default if we pass an empty lifecycle. So lifecycle has stop signal inside it, and when we pass an empty lifecycle in the container config, it falls back to the default value of the 0 value in the enum defined in the CRA API. So I changed it to a string in the PR. Stop signal is defined as a string in the CRA API, but it is an enum in the Kubernetes API. And I wanted to know what you all thought of that. I wanted I understand how it would be more efficient if it was an enum. Yeah, there was a discussion that happened around this in the API review channel, which I have also linked, where Kevin suggested that we can maybe have like a invalid signal in the enum, which we would fall back to if the
that's what I was thinking. If we have something like a -1 or something, I think we can figure that out in that one. So I think, Sriram, the main problem is I've been moving past your PR, but it's in draft stage. Unless you move it to reviewable, no one is going to look at it because there's tons of other PRs which are in ready state. So please move it there, and then we can proceed with the reviews.
Yep. I have changed it to review now, but the reason I kept in draft was I have not fixed the tests. So right now all the tests are failing. But yeah, I can we can take this discussion in the PR. Thanks.
Great, thank you. I also had a similar. Well, I wanted to just talk about I don't know if there's enough time to talk about it, but I wanted to talk about swap eviction. Specifically, I wanted to get, now that I have Don and let's see if Yuju here. Don and Yuju in the room, I wanted to talk about the current approach that Itamar has with the swap eviction, swap-aware evictions, and I just wanted to give space for you all to voice any concerns with the current approach as we're sort of approaching the feature deadline, because Itamar hasn't gotten feedback that he's been hoping for. Yeah.
Can I delegate that one to the AJ? AJ have a lot of because we talk about it in the planning, right? So AJ is going to do a lot of. Is AJ is here? AJ did a lot of the testing, validation. He actually collect way more data than Yuji and I. And yeah, we do.
Hi, I'm here. Thanks for the call out, Don. I think I interest to see. I'm not sure who started the swap eviction discussion. I wasn't able to confirm the swap eviction order during my manual testing, and I don't see enough tests to validate many of the claims from the KEP. I think we would like to see clear eviction ordering as we intend here for GA and achieve them as tests. If I think that's my state on eviction handling for swap. I'm not able to verify the especially on the priority ordering, because when node is under pressure, it's hard to get that confirmed. And another thing I think I'm concerned about specifically is the API on how we would want to see explicit swap configuration right now, because a lot of features are in intersection with swap, for example, IPPR. And I think we need to clearly define how this is going to look like as part of GA. I think that's some concerns I want to bring about.
I think the goal of this KEP right now is not to do API swap. I mean, the comments, I wrote those comments as a just sort of off the top of my head series of thoughts. But the point of kubelet limited swap was to not do API configured swap. So I think that there's space for that enhancement in the future, just by having multiple swap modes that the kubelet can do. But the point of this one was to sort of not go there. Is that satisfactory for you, or just because we've been sort of trying to narrow down on this specific use case first, and then open the door for more customizations in the future?
I think actually in the KEP design review, right? So my top concern it is in the eviction manager. So we actually create off the scenario and favor any application using swap. So the application cannot using swap because they care about the predictability about the performance and more than the disruption. So they are going to punish it immediately. That's my top concern, because the swap actually only usable to certain workload, not for other workload. And performance sensitive workload is not. So but if they have right behavior of the performance sensitive workload, there is guaranteed workload. But when there it is the state rule and happen, we have to evict something, and we punish those workload immediately. That's because we treat the swap space as part of the regular of the memory. So that's kind of my top concern from that current policy.
So yeah, so I was the one that sort of pushed for the swap. The way that we would integrate swap in this situation is considering the usable swap as part of memory, because almost functionally that's how it works. It doesn't work perfectly like that. But so would your concerns be mitigated, Don, if instead of thinking of the memory limits as usable swap plus memory, we just considered it as the memory limit? Because that would effectively then always punish swapping pods, because their effective memory limit would be memory plus swap, but the one that they would be sort of judged against would be just memory. Would that then mitigate that concern?
That's also, so that's what I need to think about. That's also is not right because the user try to enable of the swap is because that application relatively could tolerate some performance downgrade, because for them they prioritize disruption over of the performance, right? Predictable and all those kind of things. Then we punish them, which is mean we kill them, and then they have the more disruption. So that's why what's the best balance? So I feel like that we cannot just simply just combine them as the single memory total, right? So or it is separate them just brutally. We need to have some other. This is why in the original design. So AJ, correct me, because I did raise those kind of things in the CAP design. I hope in the implementation we address this problem. So and so that's but so far I haven't seen that discussed yet.
Yeah, I think it's been struggling because it's not entirely clear what the best way for us to address those
Peter.
concerns are. Like,
Yes, sorry, you're breaking.
Okay.
Your voice is broken now.
Yeah.
Better.
I think like it's still breaking. Could you try that again?
How about now?
Yeah.
Yeah. So I guess I think the difficulty that we've been having is it's not been totally clear. Yeah, we've been like, I guess, looking for feedback on the approach and have been suggesting approaches, but haven't. It's been tricky trying to get, to find an approach that seems to satisfy the condition. So I guess so. As another proposal that we haven't really talked through yet, would it then be more comfortable for you if there was basically like parallel eviction signals where like we would be thinking about swapping swap enabled pods and swap disabled pods sort of in parallel with each other, instead of punishing them, having an algorithm that would weigh in one way or the other? Because like it's either we err on the side of punishing swapping pods, we err on the side of punishing not swapping pods, or we think of them separately. Because I don't think that I think it'd be tricky to sort of find a way to sort of perfectly map the way that the kernel is going to be allocating swap in memory. So that would be more comfortable to you, Don?
Yeah, at least the previous two is not comfortable for me.
I can't hear you. I don't know if it's me.
It's you.
It's you, Peter.
Don, maybe you can say it, and Peter, you can see the recording.
Oh yeah, we ran out of time. I think this is at least better than previous two cases, right? So it's kind of because my concern it is the first use cases punish about the workload not end above the swap. So that could be abusive to using swap feature, and also is a necessary punish of the good behavior guarantee job without a swap. So that's my top concern. Second concern is we always punish swap. That's also different original purpose. I really want to swap nowadays for those batch workload, and they couldn't tolerate. They unlikely tolerate of the disruption. So maybe separate of them and have the different consideration. That's better to balance. We can iterate even more detail enhancement, but separated from beginning, reduce of the confusing and the misleading.
Yeah, another dimension here is how often processes swap. So if we just swap some initial classes from class loader in the beginning of process execution, and now they don't use swap at all, this is like great application. Let it just use a little bit of disk and let's not punish this application. But, if applications start like churning and trashing the disk all the time, it definitely may be a noisy neighbors that we don't want to have around if we have out of memory problem or CPU problem or whatever.
Manu, how do you think?
Sorry, I'm having audio trouble now, and I missed stuff. Can you hear me?
Yeah, we can hear you well.
Yeah, I think good next steps would be to list some ideas we have and maybe prove them with practice, like try to see what kind of tests we can run. Because we like ideally we need to have every proposal tested so that we can confirm that the kernel works exactly as we think it works. So we wouldn't have surprise. Ajay is working on it from Google side as well. Just one minute. Peter, I cannot hear you now.
I think like I also want to add like one more direction that I want to like take clear decisions early on about how the swap interacts with other features, like adding complexity to other feature intersections like IPPR. I think like should be held off until we make decisions on API. Swap as a feature should be self-contained and should not impact directions of other features. Is what I think. I think like we can continue discussions on this on the gap. I think like that's also something important. I think we need to decide early on and not leave it for later decisions. I think I'm a bit concerned that like omitting crucial API and security considerations for the sake of speed of delivery is a bad precedent, and we need to address these issues. At least have a clear direction now, if not include this in the GA.
Okay, we out of time and there are lots of communication troubles. Let's finish this meeting and we can resume discussion offline or continue next meeting. Thank you, everybody. Have a good day. Bye.